Okay, so today we're going to be talking about limits of infinity. We talked about this lesson, or we did this pretty much, that was the first topic that we did, right? For section 2 anyways, we're actually finding the limits of functions. Today we're going to be solving using limits to help us find horizontal and vertical asymptotes, as well as finding the limits of functions. All right. So to find infinite limits of rational functions, we're going to factor out the highest power of the variables as a common factor, right? We've done this before, so this should be nothing new for you guys. Okay, so when we are finding limits to infinity or negative infinity, this is going to be new for us today. When we do this, this is going to give us the horizontal asymptotes. So limits to infinity or negative infinity will give us the horizontal asymptotes of a function if it has one. Okay. So let's look at f of x is equal to 1 over x. Okay. So we have seen this graph before, and it looks something like this. Okay. So what do we know about this function so far?
It's got a horizontal and vertical asymptote.
Yeah, perfect. It's a horizontal and vertical asymptote. Okay. So at y is equal to 0, we have an asymptote, and at x equals 0, we also have an asymptote. Okay, so if we were to find the limit of 1 over x as x approaches infinity, so as we go towards infinity, what are we approaching but never getting to? 0. Good. Okay, so when we find the limit of a function to infinity or negative infinity, we know that the limit, that will tell us that. So we're just going to substitute in infinity over x. As that gets larger and larger and larger, we're going to get closer and closer to 0, but not actually touching it. Okay, so if we find the limit of our function, it will tell us our horizontal asymptote, so which is right here. Okay, good. And then if we approach that from the other side, so the limit of 1 over x as x approaches negative infinity, as we go this way, we're still approaching 0, right? Still approaching 0. Good. All good? Great. So now we have something like this, so we are going to take some of the strategies that we have used previously to solve the limits of this. So because it is a limit to infinity, we are going to factor out the highest power of x first. Okay, so in this case, it's just x, right? X to the 1. Good. Approach infinity. So we will have x. So we'll get 2 minus 1 over x on the numerator. And then on the denominator, we will have 1 minus 2 over x. Okay, so our x's are cancelled. X divided by x is 1. So then we'll get limit as x approaches infinity of 2 minus 1 over x divided by 1 minus 2 over x. Okay. So now we can just substitute in our infinity pretty much, okay? So the limit as x approaches infinity. So what is the limit of a constant?
It's just the number.
It's just the constant, yeah. So we're gonna have, so limit of 2 is 2 so 1 divided by infinity is 0, right? Divided by 1 minus 2 over infinity, which is also going to be 0. Good, so 2 minus 0 over 1 minus 0 is 2 over 1, which is equal to 2. Okay, so we know we will have a horizontal asymptote at x equals 2. So somewhere up there we're going to have a horizontal asymptote. Okay, so if we do that, we find our horizontal asymptote, but we can also find our vertical asymptote as well by setting the denominator equal to 0. Okay, so what value of x will make that the denominator 0? 2. So we're also going to have a vertical asymptote at, sorry, that should be y is equal to 2. Horizontal asymptote. And then we'll also have a vertical asymptote. So x minus 2 is equal to 0. 2 on both sides. X equals 2. We will have a vertical asymptote. And this should be y. And this is x equals 2. So then our graph will look something like this. Pretty nifty. We can find vertical and horizontal asymptotes using our limits. Good. Good. Any questions so far? All good? Great. Okay, let's make sure we're still recording. Excellent. Okay, so like we just did, we're going to factor out the highest power of x. So limit as x approaches infinity. So our highest power of x here is x squared. So then we'll get 2 minus 3 over x plus 1 over x squared divided by x squared will give us 1 minus 4 over x.
Would that be x squared?
Yes, absolutely. Sorry. Thank you. Good, so those will cancel. We can simplify this a little bit. 2 minus 3 over x plus 1 over x squared divided by 1 minus 4 over x squared. And like we just did, now we can solve them because it's in a manner that we're able to solve because we know what the limit of a number divided by x as it approaches infinity is, right? It's just 0. So now we'll just go in. So the limit of x approaches infinity. So limit of a constant is just the constant. So 2 minus 0 plus 0 divided by 1 minus 0. So which is equal to 2 over 1, which is equal to 2. So then when we're presenting our answers, we can say the limit of our function here, so 2x squared minus 3x plus 1 over x squared minus 4 is equal to 2. And this is our horizontal asymptote. Okay. And if we wanted to find our vertical asymptote, we can just set our denominator equal to 0. So plus 4. I'll take the root of both sides. X is equal to 2. So this will be vertical asymptote. Okay, so I can now give you guys a function as a limit to infinity, and you guys should be able to find both a vertical and a horizontal asymptote. Okay, questions? No? All good? Great. So, let's carry on. Okay, so when we have exponential functions, we cannot it's not easier to factor out x powers, okay? And when we have something other than a rational, we will have to solve it differently. Remember one of the first ways we used to find the limit of a number? We had a few strategies. We could graph it,
Make a chart.
make a table of values, right? Or solve it algebraically, or we could use limit theorems too, right? For these ones, we're going to make a table of values. Okay? So this function here is the limit of 2 to the power of x as x approaches infinity. So just going to make a table of values. We'll have x and f of x. So as it approaches infinity, we're just going to test data points that get progressively larger. So we'll do 1, 10, 100, and 1000. Okay, so if we substitute that into f of x, we'll get 2 to the 1, 2 to the 10, 2 to the 100, and 2 to the 1000. Okay, not necessarily too concerned with these values themselves, because we know that it's just going to get really, really big, right? Exponential growth. So if we were to draw this as x approaches infinity, we are also going to look at x approaching from the negative direction as well. But if we're just looking from the positive direction here, we will have x's 1 and 2, so about here. That's what this function looks like on the right side of that graph. Okay. So what could we say about this graph? What does it look like? How is it increasing? Exponentially, yeah. So exponential increase, and another way we could say this is that it increases without bound. As x approaches infinity. So therefore, the limit of 2 to the x as x approaches infinity is equal to infinity. All good? Okay, so that is when we look at it from 0 going to positive, or to positive infinity. Now this one we're going to look at that same function, except we're approaching negative infinity this time. Okay, so same thing, we're going to use a table of values, so x and f of x. But because we are going to negative infinity, we're going to start on the negative side, and same thing, just get progressively larger. And same thing, so we'll just do 2 to the negative 1, 2 to the negative 10, 2 to the negative 100, and 2 to the negative 1000. And if we were to rewrite this in a different way, this will become 1 over 2, 1 divided by 2 to the 10, 1 divided by 2 to the 100, 1 divided by 2 to the 100, yeah, and then 1 divided by 2 to the 1000. So 1 over 2, 1 over 2 to the 10, 1 over 2 to the 100. What's happening to our f of x? Smaller and smaller and smaller, but never going to actually reach 0, right? But it's approaching 0. So what do we say the limit of this function is then? 0, good. So the limit of 2 to the x, as x approaches negative infinity, is equal to 0. We're getting closer and closer and closer. So we have showed the right half of that graph, so I'm going to show the left half of it now. And so when we're at 1, or at negative 1, I would put negative there, good. So we're at negative 1, we're about right here, and then it's getting closer and closer and closer, so it looks something like that, roughly. That's my point. So that's negative 1 and 1 over 2, just to be safe. Okay, and then if we wanted to combine those two functions to kind of paint a full picture, then it's going to look something like this, right? So if we just combine, so we have the left side here as we approach negative infinity, and there's our positive infinity, so this graph here will show both of those as we approach infinity and negative infinity. Okay? Great. And this here, so we say that the limit is 0, and in reference to the last couple questions, what else does this value tell us? What is it approaching but never touching? Yep, the x-axis, absolutely. And no, we don't need the intercept, but it also tells us the horizontal asymptote of the function, okay? So remember, the limit of a function will tell us the horizontal, so. Okay, excellent. We are almost done. Last one here. So we can use our knowledge of positive and negative factors to determine the limit of any polynomial function as long as it's approaching infinity, okay? Or negative infinity for that. So in this case, so right, if we look at this one right here, what is the, what type of polynomial function would this be? To what degree? It'll be a third degree, yeah, good. So we'll say this is an x to the 3 polynomial function. Okay. And then our next step is, so we are going to be determining what, so sorry, I'll make this easier for you. So determine what each factor is approaching. As x approaches infinity or negative infinity. Okay, so that's just kind of a general what the heck we're doing. Okay, so then we're just going to literally sub in infinity. Okay, so we're going to, so 2 minus infinity, infinity plus 2, infinity minus 3. So if we have 2 minus infinity, what is our answer going to be here?
Negative infinity.
Perfect. Okay, so we're going to have negative infinity. Right, if you're subtracting negative infinity from 2, you're just going to go on forever till negative infinity. Good. And then if we have infinity plus 2,
Approaching infinity.
yeah, so we're just going to say positive infinity there. And then lastly, infinity minus 3. Still positive infinity, right? Good. And positive. Don't forget that. So in that case, then we're just going to like multiply them together. So negative multiplied by positive gives us a negative, of course, and then a negative multiplied by a positive is a negative as well. So our final answer, so the limit as x approaches infinity, and I'm just going to rewrite this again. So 2 minus x, x plus 2, x minus 3 is equal to negative infinity. Not too bad, hey? Yeah. Great. And we're going to do the same thing, but this time we're approaching negative infinity. Okay? So same thing, we're just going to substitute this in. So limit as x approaches negative infinity. And just this one, we have to be like a little bit careful with our negatives, right? So it's going to be 2 minus negative infinity. And then we'll have negative infinity plus 2. And then negative infinity minus 3. So we distribute that. We'll get 2 plus infinity. The rest is going to stay the same, so negative infinity plus 2, negative infinity minus 3. Now same thing what we did last time, so 2 plus infinity will just be infinity, good. So positive infinity, and then negative infinity plus 2, negative infinity, and negative infinity minus 3, negative infinity. Annabelle's on fire today. Awesome. Okay, so then we'll just do what we just did. So positive multiplied by a negative gives us a negative. Negative multiplied by another negative gives us a positive, right? So the limit as x approaches negative infinity of 2 minus x, x plus 2, and x minus 3 is equal to is positive infinity. Hey. There we go. Okay. I have 2 notes on here. So because the graph does not have a specified limit as x approaches infinity or as x approaches negative infinity, this graph does not have a horizontal asymptote. Okay, I'll write that down. Oh, we got lots of time. Okay, so because the graph because the graph does not have a specified value, or limit, sorry, as x approaches infinity / negative infinity, the graph does not have a horizontal asymptote. Okay, and then we can use a graph to verify this if we want, if you had to. So here's our graph. And remember our f of x was 2 minus x plus 2, and x minus 3. What will, if we set these equal to 0, what will that tell us? The x-intercepts? Yeah, the x-intercepts, absolutely, okay? So how we want to do that, so this one might be a little tricky, so if we just factor out a negative from that first one, we'll get x minus 2. And then we're only factoring that negative out of the first one, so we'll still have x plus 2, x minus 3. So how would we set this one equal to 0? Let's get right here. That's all right.
Set it equal to 0?
Yeah, so what value of 2, or x, subtract 2 will equal 0?
Yeah, so you make it equal to 0.
Yeah, exactly, right? So if x was equal to 2, 2 minus 2 would be 0, right? So here we have 2. This one, we have negative 2, right? And here we would have 3. So negative 2, 2, and 3. Okay, this negative in front will tell us that the end is going to be pointing down, and we've just found our zeros there. So our function is going to look something like this. And then we can say, as we solved before, the limit of f of x as x approaches infinity is equal to negative infinity, like we did. We've previously done that. And then the limit of f of x as x approaches negative infinity is equal to positive infinity. And that makes sense when we look at our graph. All right, so that's it for today's lesson. The associated assignment is page 45, questions 1 to 3 in your module 2 limits workbook. Okay, the solutions are in the back of that, so feel free to check your solutions with that. And also, we will continue to work on the module, like the big module assignment for the limits book. We'll probably give you Monday and Tuesday in class. So I'll give you class time on Monday, Tuesday to work on that. So I won't be doing a video lesson on Monday or Tuesday, but I will be available for a Zoom or a meeting if you guys need help as you go through the module 2 workbook, the limits workbook, okay? So again, if you need me, if you need help or anything, if you just need to touch base, send me an email, send me a text. We have the Calc Kids group, which we started. So yeah, I hope this was a good lesson and you guys are safe in your quarantine. All right.